At Astra is our mantra. At Astra to the stars. At Astra, it's who we are.
Welcome to Around Space. I'm Kent Miller. Today we're going to be talking about the case for reusable space transportation. I'm delighted to have with us Dr. Ajay Kothari. Dr. Kothari got his bachelor's in physics at Bombay University. Thereafter, he got his master's and PhD in aerospace engineering from the University of Maryland. He stayed at University of Maryland and worked there as an assistant research professor. After that, he branched out into the private sector, setting up the company Astrox. Astrox does aerospace design, research, and development, and the main customers are the United States Air Force and NASA. Welcome to this table.
Thank you very much, Kent, for inviting me here and to allow me the chance to speak with you and the audience. I would also like to thank the National Space Society and the DC chapter, DC-L5, for inviting me here. Thank you.
All right. Well, tell me, why reusable space transportation?
Well, let's start with the problem.
Okay.
What is the problem today? What is the problem? I mean, look, the problem is that it costs $50 to $60 million now, right now, at this point in time, for one person to go into orbit and stay in orbit. That's just a, it's a huge and ridiculous sum of money, and it's just not possible to make a business case for space transportation, for orbital transportation. So what I wanted to do was to find out what it is that is causing these numbers to be so high, and how can we make it cheaper and likewise. And so what I've done is to look into that and try to figure out what it is. If you look at the real cost of space transportation to orbit at this point in time, is what I'm concentrating on. The reason why it is what it is because it's not because of fuel.
Right.
The cost of fuel is maybe like 3 to 5% of
Right.
the
It's
cost
very small.
of
Yep.
very small. The cost is really what is called the FUPC, which is the first unit production cost, and the acquisition cost of that particular type of thing.
Developing the vehicle and producing
Developing
the first
vehicle and
article.
producing the first one and like that.
Okay.
So that's where the number becomes what it is. And if we want to, I mean, imagine that we go from here to California by a plane, and even 200 people going by plane. And if you were to discard that plane at that point,
Yes.
and take another one, what would be the cost in that case, right?
Right.
If we were to go from here to New York by car and do the same thing, discard the car there and take another car. So the common denominator there is that we are not using these vehicles again and again,
Right.
So looking at all those kinds of things, I mean, we sort of realize that it's possible if we can somehow or the other use the same craft again and again, and I'll show you how and what kind of a craft that is, etc. Again and again, what could that do? What that could do is just absolutely amazing.
All right.
What it could do is it could I'm not just simply talking about space tourism. I'm using space tourism as an avenue for those other things. And those other things are, if we can do this, then we can, if we can reduce the cost.
If you can transport people, you can transport other things as well.
Other things also, but if they reduce the cost, well, the cost right now is almost $8,000 to $10,000 per pound to orbit. With the kind of things that I'm proposing here, we can reduce that cost to almost like $350. per
Oh,
pound
all right.
to orbit.
I understand the Air Force asked you to look into this.
Air Force did, right, yes. Yeah.
All right, can you show us you had
Yes,
what, 8 different models?
yes, absolutely, I will.
Mhm.
I just want to also say that if we can do this, it is not just simply the space tourism part, but we'll be able to manufacture medicine of certain types much more purely, cheaply, which you could not do with the $7,000 or $8,000 a pound because you
I
have to
see.
take the equipment there
Mm.
and all that kind of thing. We can also build way stations in space, and from there we can go to Mars and Moon and other places because half the energy, as you know, the orbital velocity times square root of 2 is the escape velocity. So half the energy in going to Mars or Moon is expended in just going to orbit. So if we start from there, we are going to be
You
able
have
to
great
close the
savings.
vehicle at a much smaller size. Now, in order to start from there, we have to have fuel depots there. So we'll be able to, in this case, build fuel depots. We'll be able to use commercial transportation in this country and elsewhere in the world, actually, to supply those places. Well, many things can be opened up. It's a really a great idea, to be able to do this that
All
way.
right, well, let's take a look at the vehicles.
All right, so what happened was that a few years back, we were asked by Air Force to look at 8 different options for the same exact mission. So that is 20,000 pound payload to orbit.
Okay.
Now, and then compare these 8 options, and 4 of them were vertical takeoff, and 4 of them were horizontal takeoff, but they were all two-stage
Two-stage to orbit.
two-stage to orbit options. We found by doing this, and so we designed this vehicle, and we also did the cost analysis and cost numbers calculated, et cetera, for pound into orbit. And we found that we can bring that number down to about $350 a pound. What is the common denominator for all these things that I mentioned before and this? It is reusable space transportation. It is just being able to use the vehicle again and again. Say 200 times is what we used in those numbers. So there was 20,000 pounds of payload, which means that if you have like 40 passengers, I'm talking about passengers now,
All right.
to orbit, it's we allow 500 pounds per passenger,
Right.
for example, including the incidentals, et cetera. So that's a reasonable number and reasonable idea. All of this is possible because of this. We'll be able to sustain this chain between the number of people and what they'll pay and what it would cost to go there. So final analysis with that number of $350 a pound and associating $500 per person, we came up with 2 bounds. It was, that's less than $250,000 for a ticket.
Okay.
Now imagine this, compare that to the suborbital numbers right now. We are talking about, doing suborbital
$200,000
transportation at
per person.
$200,000, and it just gives you 5 minutes of 0 G. That's it, right?
Yeah.
And you just go up and you come down. But in this case, for another maybe $100,000 more, you can go and live in orbit for 2 days. And you can do this for $300,000, $400,000 per person. It's amazing. It can open up lots of venues, avenues for many different things that we as a country can do.
Right.
All right, so the common denominator here, of course, is reusable architecture and also hypersonic vehicle architecture.
Okay.
So here in this slide, the picture, I have those 8 options that we looked at. The 4 on the left are vertical takeoff, and the 4 on the right are horizontal takeoff. They're
Okay.
all two-stage to orbit, like I said. The first 3 are all rocket, and the last 5 are basically a combination of rockets and hypersonics.
Okay.
So we did look at all these things, and so we finally came up with the designs and the numbers, the weights and the costs, and and that type of thing, and
Yeah.
that type of. And finally, we came up with this idea or graph of what the costs are. As you can see here, in this, the expendable vehicle, which was the one all the way to the left, option 0, is almost, $8,000 to $10,000 a pound, which is what it is today.
Yeah,
Right?
that's right. Yeah.
And if you go to hybrid, where first stage is reusable, but the second one is expendable rocket, then it is half as much.
Right.
But if you really go completely reusable, we are talking about $350 a pound, which is amazing. Which would just, which would be just great to have. So with those kinds of numbers, we can do something. Now,
Now, to build a business case, you also have to do market research, right?
Right,
I mean,
right.
will the customers come?
yeah, exactly, exactly. You hit the nail on that one. It's just really very important that both of those things match, right? So what we did was to look at some surveys that was done here a few years back, where they had actually, called many wealthy, sort of wealthy and very wealthy people,
Okay.
and asked them, would you be willing to go? Would you want to go to orbit and stay in orbit, etc. And so what we did was to, but at that time the price was that they were quoting was like $20 million. This was 5-6 years ago. Now I thought that if the price can be dropped to $500,000 or $250,000, what does that do? Is that that should open up, many other people who otherwise were not able to do that. So we went back and did look at that, and it turns out that it really is a very attractive and game-changing business case that way. So we what they did was to look at the wealth distribution in the world, and basically it's a matter of trying to find a pool of people.
So as you cut price, the pool is larger.
The pool is larger, right? Yeah.
So economists would say there's an elasticity of demand.
Elasticity of demand, right? Exactly.
Good.
So the pool for the price that they had there, was like 100 people. People worth more than $20 billion. But if the price is dropped much less, then we are talking about something different. So what we looked at is 5% and 1.5% cutoff points of their wealth that they're willing to spend.
So they'd be willing to spend 5% of
5%
their assets.
total assets
Okay.
on this, and 1.5%, obviously 1.5%. So then what is the pool in that case of such people?
Right.
So 5% would be like, their net worth has to be 20 times that,
Yes.
et cetera. So that pool is 900,000 and 55,000.
That's worldwide?
For those two, worldwide.
Okay.
That's worldwide. Now, when we called them, they called them, the people who did the survey, they also found that if the price were to drop, they are more likely to want to do this, and it's like 8% if the price is $20 million, but it's 33% of those people who were surveyed were likely to do that. So, looking at all that, we sort of did take into account all that, take into account other factors, and we finally found that we can almost have 224,000 such people for a 5% cutoff points, and less for the other one. And for $250,000 price, it's even more, obviously,
All right. Yeah.
So considering all of that, we finally found that a case can definitely be made where a revenue of almost $108 billion can be had over a 20-year period.
Which would be enough to recover the cost of developing it and
It will be
manufacturing
more
it.
than enough to
Yeah.
recover the cost of developing and all that. And one would hope that there are for other reasons that the government would develop that.
All right. Let me maybe just ask you a couple of questions, because I've been involved in market research before.
Sure.
And one of the things I noticed is that people with very little net wealth are the most likely to say, oh yes, I'll spend $20 million on a ticket, right? So we had to have some scaling factors to adjust for this
Right, to adjust for that.
enthusiasm.
Right, yes, right, yeah, that's true.
Did you
Also.
have to adjust?
No, I mean, the survey was done by another
someone
company,
else. Okay.
and what we did was to just look at the survey numbers and,
Okay.
and We'll have to go back and see.
Yeah.
All right, so now that's part of the story. So now, it's possible that, that we can find enough number of such people. Obviously, there are 4 combinations here, 5%, 1.5%, and $500,000 and $250,000 tickets. So there are 4 combinations. Of those 4 combinations, 3 of them were able to close the business case. 1 of them did not. No?
Yes.
Okay. Now, the next part is what kind of a vehicle we are talking about, right?
Yeah.
So people would want to know. So these are rockets.
This is one of the 8?
One of the 8
Okay.
options, right. So I want to talk, for a few minutes about what kind of vehicle here. That vehicle is the hypersonic airplane. The hypersonic airplane works on ramjet and a scramjet, basically. And it does not have to carry the amount of LOX that a rocket would have to carry.
Liquid oxygen.
Liquid oxygen.
Is this a model of it?
That's a model of it, right? Yeah,
All right.
exactly.
So it has I see it has a very highly angled wing.
Highly angled wing.
So
yes.
for high Mach number.
For high Mach number, and
It has
it
inlets here?
2 inlets there.
All right.
And a combustion takes place in the middle.
Right.
and
Now
then
this
the
model
nozzle.
opens up, yes?
It opens up, right? Correct.
All right.
Yes. And you can see here, this is where the passengers would sit
Okay.
on the side.
Or the payload if it were
The
cargo.
payload, if
Yes.
it was cargo, right? Yeah, exactly. And here is where all these tanks are, the hydrogen tanks and methane
Okay.
tanks and like that.
All right.
So this was designed in a fair amount of detail.
Yeah.
And here are the 4 views of that vehicle also. And this was, we did the detailed design of the internal structure with Boeing. And here
Okay.
is a view of that also. So then,
So let's see. So the green areas on that curve, that's where you have the hydrogen.
yes, that's
All right.
correct, yes. The
And-
green area is,
and
no,
the-
green area is not. The blue area is where
So the
we
blue,
have the
right.
hydrogen.
And the lavender or the purple
lavender or
area,
purple
that's
is
where the
where
oxygen's.
No, that's methane.
Methane.
Yes,
Oh,
right.
okay.
And oxygen is cylindrical tanks, sort of just on the 2 sides of the payload bay. The orange is the payload bay.
I see. Okay. Orange is the
passenger.
payload bay.
Right. Yes.
Okay.
So,
All right. Fascinating.
so it's effectively it is. I think it is eminently possible to do this. What we can do is we can do with this. We can do 0G manufacturing. We can do fuel depot. We can do debris removal of defunct satellites, which are about 7,000-8,000 right now. We can service the workable satellites. We can go from build a base station, go from there to Mars. All that can happen if we develop reusable technology, reusable architecture, and like that.
Because one of the questions that has been with the hypersonic technology is heat transfer.
Right.
And I was wondering, how do you keep your passengers cool and safe?
Right. Yeah. The heat transfer occurs on the surface and the internal side.
Yeah.
And we have TPS systems, and it
Thermal
includes
protection.
thermal protection system, which includes active cooling and passive cooling both,
Okay.
depending on what the temperature is. And of course, you know that liquid hydrogen and liquid oxygen tanks and liquid methane tanks are at 200, 120 degrees Kelvin
Okay.
temperature. It's very cold.
So there'll be some boiling as the heat goes in.
There'll be some, it'll heat, but we use, normally what you do is you use those cold fuels, make them pass through the active cooling regions and cool them
Okay.
with that.
I see.
So,
Okay.
so the heat does not go to the payload bay and to the passenger.
Right.
Obviously, we have to make sure
You have
that
to
that
protect
does
your
not happen.
payload, yeah.
Right, yeah.
Okay.
But the interesting thing is that this is the vehicle that I showed here, this vehicle, for example, it's sort of a segue into what happened, what in 1968, the movie 2001: A Space Odyssey, when it
Oh
was
yes,
made.
yes.
you know.
Uh-huh.
And so I brought a clip of that to show that it is uncanny how much of a resemblance there is between that and what we are proposing here as such. So if I may I show that at this point in time?
Sure. I'd love to. love especially the nice shaped wings on that vehicle.
Right,
just-
yes,
you-
right, yeah. And so here we have the internal compartment, and of course, you can see there are seats in there, and people, and the vehicle looks similar to this one, but it was a rocket. There was no hypersonic airplane at that time.
I guess people are walking with Velcro on the floor. I
People
guess.
were walking the Velcro on the floor,
They
et
don't
cetera,
float
et
away.
cetera, and they float away. And so it is amazing that we were able to think of all these things at that time,
Yeah.
almost 50 years ago now. And we haven't, 2001 has come and gone. We should do this, We should do this, that we can do this and we should do this.
Yeah. Well, I understand you have some recommendations, or some conclusions and some recommendations
Yeah,
to,
right, yeah.
to our political leaders.
Yes, well, yes, I guess. I would really think, I think that this is what we need to do is that NASA and Air Force should develop completely reusable, robust, and quick turnaround, something
yes,
that can be
that's right.
turn around quickly, type of technologies within those labs at NASA and Air Force. It can be done, it should be done. If we do that, all of these possibilities open up.
All these new
It would
business
be no
possibilities.
New business
opens up,
possibilities.
Yeah.
So it is not just simply, move us forward, including hypersonics. It will not just move us forward as a civilization, but it'll, benefit us economically also at the same time as a country, because it'll open up lots of jobs and jobs that will support those people, those ideas.
Yeah.
It'll open up all that. It'll keep us as number one in technology around the world, because lots of technologies that'll be required. That'll be required is going to be addressed here.
Okay.
Lots of technologies will be addressed, and and it'll also allow us to explore space in a fantastic manner and cheaper, and with participation from many people from all over the
Basically,
country.
low Earth orbit becomes a low-cost platform
Low-cost
from which we can
platform
go
to
everywhere.
Yes, it can be done.
Okay.
This way.
What would you tell our political leaders?
Well, I would tell them to. Really
Do
push
it.
this
Push
idea.
this.
Push this idea.
All right.
Reusable space transportation.
Thank you very much,
you very
Dr. Kothari. And thank
Thank you.
you very much for being with us, and see you next time out around space.